Hey guys, welcome back. It is States of Matter Notes Part 2. I found a friend.
Hi,
Hey bestie.
kids.
All right, ready for the joke of the day?
I don't know if they can handle this one.
Well,
Well, we'll see.
okay.
Okay.
We'll experiment. It's experimental.
It's experimental.
Okay.
Hey, you gonna finish that Adam?
No? You want to split it?
Boom.
And she's gone. She left. All right. Okay, so what you are going to need is this paper that is already in your notebook. It's 2.1C. You have filled in the top three boxes and you filled in the top of the next three boxes where it says 2.1C. And now we're going to do the bottom part, which is particle spacing and motion. So we're going to do a little bit of writing and a little bit of sketching. So here we go. Let's get to it. All right. Can we do that? If I do the slideshow, ooh, they go away. All right. So we can develop models. That's our goal that describe the spacing of motions of particles and motion of the particles of solids, liquids, and gases. Okay. So this is the paper that you're going to be using. You're going to be filling out this section down here and this section down here and this section down here. And that is all. All right. So as we look at this, this is a model that you'll be responsible for being able to draw and explain. And on the left over here, we have, as you can see, we've got a solid. All of the molecules or atoms, whatever you want to call them, particles are close together. Over here, so we'll put a little S for there. And over here, we've got some liquids in this section right over here. And they're close together, but they have the ability to move and there's more spacing in between them. And then the last one is we have this gas. And in this gas, you can see the particles are completely spaced everywhere. And that's what we're going to get started with today. So by the time we're finished, if I said to you, could you draw a model of solid? Hopefully you'd be able to draw this. If I had you ask you to draw a model of a liquid, hopefully you'd be able to draw this, and a model of a gas. All right, so here we go. So let's clear the screen and let's go back there and let's go. All right. So solids. You'll pause when you need to. You'll write this information down. There's the spacing. The spacing is that they are very close together and it's a very rigid structure, like a table, like a can. The way they move is that they, believe it or not, all solids, even ice, a table, a cat. I don't know why I said cat, but all solids are going to vibrate and they vibrate in place. If they're colder, they vibrate a little less. And if they're warmer, they would vibrate a little more. But all solids are close together for their spacing, and their motion is that they vibrate in place. So you'll make sure to write this business right down here. This is a really thin looking pen. And then you'll also write this part right here. And then go ahead and pause and add a picture. Add this little picture off to the side of the solids. Now, liquids, when it comes to the molecular model, their spacing is also close together, but there's more space in between the particles that you can see. For the motion, they kind of move around randomly, they collide with one another. Um, you'll write this information here, you'll pause as you need to. And remember, these are things that, we can watch liquid flow from one container to another. And it's those small particles that we can't see the small particles, but we see them all together as they move and they're bumping around each other. And if you're pouring soda, you see the bubbles and how they're mixing around. You'll also, in this second box, you're going to make sure, hey, that's back to me again. You're going to make sure to do your sketches right over here in these sections here. You'll do your sketches for all of these. And our last one are gases. And the spacing is very wide. You can see that There is way more space in between these particles. And their motion is that they just move around randomly at high speeds. If they're in a closed container, they will bounce off of the container. If they are not in a closed container, sometimes they'll bounce off of each other. And in eighth grade, you'll learn one of the Newton's laws of motion is that any object that hits another object will continue in a straight line until it is affected by another object. So essentially, gases are just going to kind of go on forever unless gravity gets in their way or they hit another particle or gas. Make sure that you're writing down this information that's here. Make sure you're writing down this information as well on your paper. Make sure to pause. And also, if you want to make sure to drop a little sticker there for you, make sure that you're drawing how the gases are moving, how you can show them separating. That's also really helpful. All right. Now, in gases, you can see here on the left that some gases, when you have gases and you try to compress them or squeeze them, since there is spacing in between them, you can squeeze them closer together. Now, if they become closer together, what phase of matter is that? Right, that's a liquid. And so squishing gas can actually make it into a liquid. Now, the liquid, however, they're already close together. And so squeezing them close together, when it comes to pressure, the liquid is not going to come and press together and become something else. It's going to stay a liquid. It is a lot harder to move. It's a lot harder to put pressure on a liquid than it is a gas. Gases are much easier to compress. Why? Because there's more space in between them. You got it. Oh, my page just stopped working out of nowhere. Holy moly. Let's check this out. See if we can figure out what's going on here. There we go. Woof. I'm not starting that video over. All right. All right. Where were we? We were right. Oh, reload again. Holy moly. What is happening? Here we go. We'll take this one. There we go. All right. So, to give you an idea about particle moving, this is what the particles of a solid look like. They are always moving, always, always. Now you're moving into more of a liquid where they're moving around each other, they're colliding a little bit, and now you're hitting that gas section. Right on, right on, right on. All righty. There we go. All right, so we'll go on to our next one from there. All right, so this last part here is about developing models. And when you develop your models, I'm going to have you practice over here. We can get this paper there. Can we get this paper there? Here we go. I'm going to have you practice in these sections over here. Because when you draw your models, you need to be able to show that your models are actually moving. So with a solid model, I know it sounds weird, but yes, particles in a solid are always moving. And so you'll just draw one line, one line, one line to show that they're vibrating, just one line. So go ahead and pause and do that now in the solid section. So right over here in this solid section, this is where you're going to draw those small lines. You want to make sure that you've got those. Now with liquids, let's go ahead and see if we can clear this page here. There we go. All right. Now with the liquids, since they move faster, we want to put two lines. So go ahead and add two lines. And you don't have to add it for everything at all. Just a few of them is in good shape. There we go. You want to kind of give two separate lines down there because that shows that liquids move a little bit more. Now with gases, gases are going to be moving the fastest. So instead of one line, not two lines, but yeah, you got it, three lines. So having three small lines, making sure they're separate, that is how you model. I know my my lines are straight, not so great with this pen here. But as long as there's three lines, then I understand that you're telling me that they are moving more. All righty. All right, guys. That's it for today's notes. Enjoy yourselves. Have a great day.